Alright, how's it going, y'all? So today, we're going to be going over how you can expand the capability of your Synology NAS to running millions of different apps, programs, services, anything you can think of that you want to run on a server. You're almost certainly going to be able to do it using Docker. So Docker is a phenomenal thing that can just allow you to run so many different apps and programs on the NAS, even though they were not specifically developed for Synology NAS. Docker containers are also incredibly efficient when it comes to RAM and CPU utilization, and so you can run tons and tons and tons of them, all on pretty basic Synology NASs, which is really nice to have for people getting to their home lab or who just need to spin up a bunch of different services and things like that. There is almost unlimited potential as to what you can run on these things. From my own experience, unless you're actually doing video processing or data transcoding or anything that's really heavy CPU intensive, you can run pretty much anything you can think of pretty safely on even a dual core CPU Synology NAS with only like 4 gigs of RAM, and you probably will be able to run tons of things. I've seen people run 15, 20 Docker containers on a Raspberry Pi before, and so it is very powerful because it's so efficient. This tutorial is going to be going over how to use Container Manager on DSM 7.2. So back before DSM 7.2 and DSM 7.1 and before, the package was called Docker. And Docker was simple because you saw Docker in the package center and you're like, that runs Docker containers. Now, because I assume because of trademark reasons, they are not calling it Docker, but rather Container Manager. I believe they may have switched the actual binaries from actually using the standard Docker one. And so I don't think they're able to actually use the Docker logo and the Docker trademark. Don't quote me on that, but I assume that's why they've changed it. TrueNAS Scale has done the exact same thing. They're called containers over there as well. I think it's just because of trademark issues, but don't quote me on that. That is just my speculation. So there is no difference for the most part between Docker and Container Manager. If you upgrade from DSM 7.1 to 7.2, Container Manager will just automatically start up and all of your containers will just start up exactly how they were on DSM 7.1. Pretty much no changes there at all. That is with the caveat that everything has been set up properly on the containers. If you're not properly set up configs, you may be in trouble if you don't have persistent storage, and the containers were expecting persistent storage. But we'll be talking about that more on that later because it's also going to be a key component to making sure your Docker containers that you're deploying are healthy. So with that being said, any tutorial you see from now on that references Docker, so all the old tutorials that Morris has done and anybody's done, and I've done a bunch of them, that say go ahead and install Docker, well, that just means go ahead and install Container Manager and you're going to be able to do all the exact same things. So do not worry about it. It's going to be very easy. You can still use them exactly how you have been. It's just an annoying name change that makes it hard to communicate. But first, I'd like to thank Dragonfly for sponsoring this section of the video. Dragonfly is a modern open source in-memory database that has been developed to provide increased performance and reliability compared to its predecessors. One of the key reasons why Dragonfly performs so much better to its predecessors, such as Redis, is the fact that it's actually multi-threaded rather than single-threaded. This means you can actually just scale it vertically by building a higher spec single workstation or server with multiple CPU cores, rather than relying on scaling horizontally by actually having multiple instances of a server or even across multiple clusters and things like that. And so it's a much more simple setup for the increased throughput. Dragonfly is built to utilize modern cloud infrastructure, meaning 25 times the performance compared to Redis on the exact same instance size. This allows workloads to be run on half the resources, dramatically reducing infrastructure costs. When tested against Redis, Dragonfly was able to achieve much higher throughput. In addition, because of Dragonfly's increased efficiency, it does not suffer the performance losses during the snapshotting process that Redis commonly does. Dragonfly is a complete drop-in replacement for Redis, meaning you can easily migrate from Redis to Dragonfly without any downtime. To learn more and get started with Dragonfly today, visit the link in the description. All right, thanks to Dragonfly for sponsoring this section of the video. Now back to the tutorial. And so now let's talk about what Docker is and why it is so powerful and why we're going to be able to run so many things on our Synology NAS so efficiently. And to start, we have to first think about how complicated software development was before Docker and even now for people who do not deploy using Docker. And so let's just say that I'm a software developer and I am building a new type of server. Say it's a better type of Minecraft server. Who knows? Maybe it's a better database server. Maybe it's a better way to host a WordPress instance. Maybe it's whatever. Say I want to get this out. I want people to start deploying it. Well, now I have to figure out how to make it on Windows. I have to figure out how to make it on Mac. I have to figure out how to deploy it on all 400 different Linux distributions who are all using different package managers and also have slightly different configurations between all of them. I have to make sure that a bug found in Windows does not break something that is fixed on Linux. There are so many complicated parts about that made it incredibly hard to actually develop these things, because now you don't have to just care about it working on your system. It has to work on thousands of different configurations and systems. That's where Docker came in. Docker packages all that information up into one piece, one container that actually contains the entire, essentially, operating system of that system, because it actually is the full operating system. A Docker container is actually very close to a virtual machine. So it's essentially got its own operating system, its own shell, its own configurations, its own binaries. Everything itself, it actually is running by itself. The only thing it shares is the kernel. We're not going to really talk about that here because it's unnecessary, but essentially just think about Docker containers as small virtual machines that are really efficient when it comes to RAM as well as CPU. So now you can have this single Docker container, and if it runs on Docker on Windows, it'll run on Docker on Linux and Docker on macOS, pretty much without any custom configuration across the board. The one place where that is slightly untrue is when it comes to different actual CPU architectures. And so an ARM CPU and a Intel x86 CPU necessarily are not going to be able to run the same Docker container in the exact same way. But other than that, it's very, very, very efficient and very easy to develop for. And so that's the beauty of Docker. Docker has allowed all of these developers to create these phenomenal applications and programs and services, all without having to worry about making sure it runs on Synology NAS. If you open up the package center, we can scroll down and we can see that there's a few open source packages down here that people have developed and added on in. There are just a few of them, right? All of these packages had to actually be developed with Synology in mind. They actually had to port their code over to run on Synology's DSM. And so that's why there's very few of them. Docker does not have this issue because if it runs on Docker container, it runs everywhere. All right, so now let's go over the really basics of what a Docker container is. And I'm not going to spend too much time on this, but there are really, in my mind, three key components to an actual Docker container being deployed and running. First off is the actual container itself. So Docker containers have their own images that are essentially their own virtual machines in there that have all their configurations and every single thing they need. So say you deploy a WordPress instance. That may be built off of a Linux instance that is actually running a full Linux virtual machine in there, essentially, that has all the different things that WordPress needs to run a WordPress site. And so that is the really key component, the base image. Now, the next really important part about Docker that you always need to remember, and we'll go over this here, is making sure you give it the right volume. So Docker comes with its own file system. Whenever you deploy a Docker container, you deploy an entire file system. So it has its own repositories, it's got its own user folders, it's got everything built in. And then what you have is what's called a volume. So what you can do is you can say, hey Docker, when you see this folder on the file system, it's not actually part of the regular container that I downloaded from docker.io. It's actually part of the actual regular file system. And the important part about that is it persists. And so I'm going to talk about that here in a minute, but whenever you see a guide setting up a Docker container and it has a volume, you need to make sure you save that volume on persistent storage. Almost every single Docker container will work just fine without that until you ever have to update the container or anything like that, because at that time, Docker will blow away everything and rebuild the container from the base start with that config file. And you will lose any configuration you've done. And so if it was WordPress, you would lose your entire WordPress site. We'll go over that. It's really easy to do. Just don't forget to do it. And the third part that's very critical is the ports. So I'm not going to go over in depth here on Docker networking. There's a ton of stuff there, but we're going to keep it super simple. Whenever you're dealing with Docker ports, basically think that Docker runs on the same IP address of your Synology, except it gets to bring its own ports. And so you can say, hey, whenever I go to the Synology's IP address, this port, actually just take me on over to the actual Docker container. And those are the three really basic parts to setting up any Docker container. And then the rest is just customization based off of whatever you're deploying. All right, so now with those basics out of the way, let's talk about how to start deploying Docker containers on a Synology NAS. And the very first thing you need to do is you just come into the Package Center and search for Container Manager. For me, this is a test system. Just go ahead and install it. It was broken because I probably broke something at some time. And it's going to go ahead and install. Quick side note, if you do not see the Container Manager in your Package Center, it's likely because Docker is not compatible with your model. You need to check the compatibility list to see. I don't believe all ARM CPUs have Docker on them or Container Manager. That is an unfortunate thing. There are ways around it. Those are unsupported, but you can do some Googling and figure out how to get it on there if you need to. All right, so now we're going to go ahead and open up our Container Manager. And this is a very basic interface. And for people who ran Docker previously in DSM 7.1 before, it is very similar with just a little bit new flair. I'm going to start with just talking about the really basic parts. The first thing to look at is the network. Next up over here is the registry. This is where you can easily find pretty much any container you would like to run, just right in here. And they're sorted by favorites and things like that. So anything you would like to go ahead and start deploying, you can find in here. And if it's not on the standard Docker registry, you can actually go in and find them online and actually add in additional registries right here. All right, so then once you go ahead and download one of these things, and we're going to be doing a get T instance. So this will be what we're going to be installing today and kind of going over. We'll just go ahead and double click it to download. And you get to choose a tag whenever you download these things. For the most part, I would recommend using latest, unless you have a custom CPU that you need to, but latest normally works. I'm just going to go ahead and choose the latest tag. And it's just going to go ahead and download the image. All right, so now in our images section, we can see that it has downloaded the entire image and it is now located here. Anything you download will automatically put it in the images section. Next up, we have our running containers, where we can either import or create new ones. And finally, we have our project tab. Projects uses Docker YAML files to actually deploy Docker containers. And that's actually what we're going to be using today to understand how to very easily deploy a bunch of things on Docker. Finally, there's the overview section, which is where we started, which is exactly what you expect it to be. It just has a very simple view. All right, so we've downloaded this image right here. Let's go ahead and figure out how to deploy it. The easiest way to do that is find their documentation. So right here, you can always just Google whatever service you like to run and Docker, and you almost certainly will be brought to a guide just like this, which is how to install it on your specific system. And what we see right here is a YAML file. So these are YAML files that allow us to very easily deploy these things without having to type in a bunch of configuration, and you can actually save these things off very easily as well. And so these YAML files are very easy to work with. And so we're going to go over how to actually do it here using a YAML file and how we can configure it to work exactly how we would like to. And so as we scroll down, we can see that there's a lot of different options for the YAML files for different ways we can deploy this. So for example, this one right here actually has multiple containers being deployed for the single one. So it's got not only the get-t server, but it also has this depends on, which means it deploys an additional database Docker container. So you actually have two different containers running from a single startup. So there's a lot of stuff you can do there. I'm not going to go over it because it's a little bit more complicated and this is a basic video, but there's tons of configuration you can do in your Docker YAML files. And this contains everything we need to work with. So we're just going to go ahead and start with the most basic one, and we're going to go over how to set this all up. So I'm just going to go ahead and copy all of this. And now we can go in to our project tab. But before we go ahead and create a new project, let's go ahead and just create a new folder for it in the Docker tab. So we open up Docker. Let's go ahead and hit create and create a new folder. And we're going to call this get-t. So every single new project or Docker container you create, it's a great idea to always just start by creating a new folder in the Docker container. And one thing we're going to do to speed this up is an important piece we've got right here is the volumes. And we can go ahead and see that this right here is a real volume. And so we're just going to need a single data folder in there to do it. I'm not going to go into it too much here, but these two volumes aren't real volumes. They're just saying what the time zone is. So don't worry about it. So we're going to skip those two steps. Instead, right now, we're just going to focus on this get t volume right here. And so we're just going to create a new folder because that's where the configuration is going to be stored. And this is that really important step I mentioned earlier about making sure that you always have your Docker container config stored somewhere. And so that way, when you update to a new version of the container, it automatically still has all the configuration you had in the past. So we just know there's a single volume we need. So we're just going to create a new one in here called get t data. And if there were multiple pieces they wanted in here, we could do that. I'm going to go ahead and delete these two out because in our case, we don't need to bring the time zone on in. So we'll go ahead and just copy it again. And now we can go back into Container Manager and start our new project. We're going to go ahead and call this project name get t. And our path, we're going to select as that folder we just created. And now we can either upload if we had saved it locally, or we'll just create it right in here and paste it on in there. So now there is some extra custom configuration here that's a bit more complicated than what you normally would do. You don't have to worry about it for the most part. For example, this is making sure that it's only run on a local network and it's not external. There's a bunch of little pieces in here that every Docker container may have for optimization. Would not worry about too much. The important sections are going to be something environment. Environment is where you can have custom configuration, environmental variables. And so that's where you can go in and say, hey, I want this setup rather than this setup. So we look in and how it's deployed with a custom database. In the environmental variable right here, it actually has you input the database, type, host, username, password, and everything like that. And so those go in as environmental variables. So we could add those here. Then more likely than not, you'll see this guy right here, restart always. That just means if the Docker container ever crashes or anything like that, it'll automatically restart. Network is where you can actually have its own custom network. We're not going to talk about that too much here. It's extra complexity that is associated with Docker that you can do. Now there's the important pieces is the volumes and the ports. These are the important things that I was talking about earlier. And just to keep this example pretty simple, we're going to go ahead and just delete these two time zone ones because all this is doing is setting the time zone to whatever your local one is, read only. We're going to go ahead and just skip that because it's extra complexity. So this right here is creating that data volume. So the first one we see on the left-hand side is where it is on your local Synology. And then the one on the right is where it shows up in the Docker container. We are going to want to go ahead and put this in that folder we created for it. And we're going to be using the absolute path for this. So we created a folder right here called Docker get t data, right? So we can see that right here, this is its full volume path. And so we're just going to go ahead and copy that on in. So we're going to say, hey, Docker, create a volume on that folder. So basically what's happening is when the actual container looks for its /data folder, it's going to find this folder we created on our NAS. And that's going to be how they communicate. And so that way it has what's called persistent storage. So I'm just going to write that on in there by pasting in that exact path right there. Now, finally, there's those ports. So get t runs on port 3000 for the web interface and 22 for SSH. So the port on the left is what it is on the host. So what it is on the Synology. So if I go to ds1522.local:3000, I will be brought to port 3000 of the Docker container. And if I do the same for port 222, I'll be brought to port 22 of it. So that's how that works. So you could say this is whatever port you want it to be. So if I wanted to access get t on port 3500, I could set that here, but keep the ones on the right the same because that's what the container is expecting. And so it's similar to port forwarding on your router where you can have a port move. And that's pretty much it. Now we can just go ahead and hit next. And we can also even set up a portal via web station. That's where we would essentially just have a really basic one click to open up get t. But we're not going to bother with that. You have to go ahead and install web station. I'm not going to bother with that here. So now we're going to just hit done. And what it's going to do is it's going to download that Git, which we've actually already downloaded, so it downloaded instantaneously. And it error code 0, which means it was successfully run. We can now see that Git is up and running. And we can go ahead and open up and see that there is the container right here. So the project contains possibly multiple containers, just like how I talked about it over here with multiple databases, where you've got a database as well as a container. So there you actually have 2 containers for one service. But in this case, we only have 1 container for this. So we can see it in our container tab. And we can actually go into the details right here and just look at the log. So we can see right now, it is just working on some stuff. It is going ahead and doing its first time setup things. So it's pretty basic. You'll also see that it's generating stuff in that /data folder we talked about earlier. And so if we open up File Station and go into Docker Git, we'll first see the compose.yaml file that we customized earlier. And we'll also see this right here has data that has been added on in. So this is data that has gone in and the container itself is building. If I deleted this SSH folder right here, it would be deleted from the actual container as well under that /data folder. All right, so now let's go ahead and just hook up to it. So we're just going to go to that same IP, except port 3000. And just like that, it has gone in, and this is the Git folder. We can see that since we did not specify the database type in the environmental variables, it is just going to ask us. And SQLite 3 is a flat file that you'll often see. And so you can see as long as it's on that /data folder, it will persist between reboots. You can customize it here. It depends on the exact customization for every single container, but you will go ahead and do this. You'll notice that everything that has data is stuck in the /data folder. That means we make sure that it will persist between reboots. And so now there's the one piece we need to update. We need to update this SSH server port to port 2222 because it's not 22 on the host. That's the one piece, because remember when we were setting this up, we said that send port 2222 to port 22. So that's the one customization we need to tell Git about. And now we're just going to go ahead and hit install. And so now, just like that, it's gone ahead and installed. We can go ahead and register and do all the normal stuff. For Git, it automatically has this, but these are all just basic things here that we can go ahead and get started with. It has just built this entire thing. And now let's go ahead and kind of just see what's going on under the hood. If we open up our actual file station again and see the Git data, we can see all these pieces have been added in. If we add a new project, a new repository, it's going to be stored in the repository folder. So we just created a new repository over there. And so it should just be added into my repository folder. Boom, right there. So you'll see that that's exactly how the file system's working. It is just taking that /data folder, and Docker knows to stick everything important in there. Whoever wrote the container knows anything that's stored in /data means it will actually exist between reboots and also reinstalls. So now one really cool thing we can go ahead and do is we can actually just use that exact same config file and just keep running. So let's go ahead and actually delete the entire project. We're going to stop it first and just delete it. But it has not gone in and deleted this folder. So we still have the compose.yaml and we have the Git data. So actually all we have to do is reuse that exact same project. And it's automatically going to find that there's a docker compose.yaml in there. And it's saved from before. Now we can actually just hit next and deploy it again. And what's actually going to happen is our Git folder and container are going to start up exactly how it was before we deleted the entire project. Because the way Docker works is it stores all those configs in that /data folder for this container. It's going to be container specific wherever they put it. But for the most part, it's almost always going to be in a /data or thing like that. Sometimes it's /config, whatever the volume is. And so now we just rebuilt the thing. And let's just go back in here and refresh our page. Nothing has changed. We didn't even have to log out and log back in. Our cookie actually was still valid, even though we completely deleted this container not 2 minutes ago. So that is the cool thing about Docker. And that's actually how updates work. Whenever you update a Docker container, it actually deletes the old container and re-downloads the new container and just updates in place like that. And so that is how containers work. All right, so now the last piece I want to talk about really quick is the other way to deploy stuff. And that is actually using the create on containers. And so we can take a container and do the exact same thing that's in the YAML file, except now we've got the UI to do it. So we've got the regular enable auto restart and things like that. And now this is where we can import the ports and volumes and things like that. So these are all the basic ones that are expected, where you can actually go in and say what the port settings are, just like this. This is actually exactly how you were deploying containers on DSM 7.1 and before on regular Docker. And so you can still do it. All those previous tutorials work exactly like this, where you've got the exact same data from this YAML file right here. It's just now it's in the volume settings and kind of broken out where you've got to type it in one by one. That's the really nice thing about having the actual YAML files, is because it makes them so easy to deploy and redeploy and change and things like that. So we could build the exact same stuff that's in the YAML file manually using the actual GUI right here, which can be useful for people who don't really have a ton of understanding of what's going on and don't like dealing with text files. Instead, you can just look at exactly how it is. Though from my experience, almost all Docker container guides at this point are really just showing you how to use it on the YAML files, because it's so much easier and it can be actually tracked with something like Git. So you can actually version control your YAML files, so you can always be deploying containers and have very basic changes to configs go ahead and last for a long time. So you will notice a lot of people are now just designing guides for actually using YAML files. And so I did just want to mention that you can do all the exact same configurations through the building of the container. And you will see that on previous guides, because back before DSM 7.2, that's exactly how you had to deploy Docker containers unless you wanted SSH in. Now you can just deploy them directly with the YAML file, which is very nice. All right, so now finally, let's talk about how to update Docker containers. So as I said earlier, every single image is basically its own version of a Docker container. And so there's two different ways to update the containers, depending on if you're using one-off containers or if you're using projects. If you're using one-off containers and a Docker container needs to update, you'll actually just get a notification right here that says, hey, this guy needs to update. And you click update, and it'll actually restart the container. So it'll actually rebuild the container, where it'll blow it away and then put it right back where it was with the new version of the container. So if I want to update to Git next version, all I have to do is basically blow away the old one and rebuild it. And now Container Manager does that automatically. By automatically, I mean one click button push. It won't just automatically update and blow away the container midway through the workday. If you do want something like that, where you want automatic updates, where it actually shuts the thing down and updates it without you ever coming in, look at installing Watchtower, which can do exactly that. If you're doing it with projects, just as we did here, updating it is actually very trivial. It's a two-step process. Simply come into your project and just stop it. So we're going to just stop it, and then we're just going to rebuild it. Because every time you rebuild it, it will pull the latest version of the container based off of what is in your YAML file. So we can just hit build. And now what it's going to do is it's just going to rebuild the container with the new version. That's because in our YAML file, we pulled the Git latest right there. That means that it is going to always try to pull the latest version. So if Git next version comes out and we rebuild it, it is now going to pull that new image for that one. But once again, we don't have any real appreciable downtime other than that 2 or 3 seconds it takes to deploy the container, because all the real configuration is done and saved in that /data folder. It's actually really cool and allows you to update stuff incredibly quickly and incredibly safely, because whoever builds a container knows exactly what version of every single piece of software you are actually running. All right, well, that should be it for this tutorial. Docker is a really powerful way to expand the capabilities of your Synology NAS. The most important thing to do whenever you're remembering this is to make sure that these config files are backed up and you have them. A really nice thing you can actually do is use snapshots on them to go through and snapshot them every hour. That way, if you mess up a config, you can actually just copy back the config as it was an hour ago from the snapshot. I talk about that in a lot of other tutorials, so I'm not really going to go over it here. But Docker has a ton of potential and a lot of really cool stuff you can go with it. There are so many things you can run on your NAS, and the beauty of it is they're separated. So if you mess up and you actually accidentally get a Docker container, have a virus or anything like that, and you blow the entire thing up and you misconfigure something, it's not that big of a deal because it is not part of your Synology. It's a very safe place to work because nothing you do there is reflected on the Synology except for that one folder that's exposed and those ports. And so it's very rare for an issue with a Docker container to ever come up to the Synology. That's almost impossible. Go and leave any other tutorials like see me make in the comments below. If you want to hire for me a project, there's a link for that in the description below. All right, have a good one. Bye.